So when we design spaces, we tend to think a lot about the aesthetics, the lighting, acoustic panels, sound masking, making the space comfortable for the occupants, whether that's the look, the usability of it, or thermal comfort, right? We want it to be somewhere that we're enjoying the space, but we often overlook indoor air quality, and we talk about just 8 cups of water every day. That's tangible, it's obvious, and we probably would make sure that we're drinking clean water, but we're taking so many breaths a day that we're breathing in 2,500 gallons of air on average, and 90% of that is indoors. And before the pandemic, I don't think many people really thought much about what they were breathing in with each breath. And as we said, we're certainly learning those lessons the hard way, and coming out of the pandemic, there's certainly opportunities to improve that every breath we're taking.
All right, let's go ahead and get rolling. Welcome to the Engineers HVAC Podcast, where it is our mission to empower and educate the HVAC community. This podcast is brought to you by Insight Partners and Hobbs & Associates, 2 commercial HVAC rep firms. I am your guest host today in for Tony Mormino. My name is Chris Adams with Insight Partners and the Hobbs Group, and I'm the Vice President of Engineering. Today, we are going to be discussing holistic strategies for enhancing IAQ in commercial environments. And today, we actually have 2 guests today. Our main speaker is, they're both from Fellows. Jason Jones, he's going to be our presenter today, is the Senior Director of Field Sales, live in that hotel room in Allentown, Pennsylvania, due to some flight cancellations. Welcome, Jason. How are we doing?
Doing good. Rolling with the punches today.
And we also have Mitch Rydholm. He's actually the Director of Training and Dealer Development. He's actually located in the Fellows showroom over in Chicago. So welcome, Mitch. We'll go to Mitch later. He's going to try and give us potentially a little tour, but just wanted to make sure that we've got what's going on. Jason's been with Fellows for 6 years. And then Mitch has been there a short 27 years with the company that has been around for 107. So it's great to see you guys. Obviously, we're thankful for everybody that's coming online with us today to watch this, and looking forward to another productive podcast. And so with that, why don't we get right into it, Jason? I'll just turn it over to you, and let's see if we can't get started and understand more about the IAQ.
Yeah, sounds great. If we want to just kind of pop over to the next slide, I appreciate it, since I'm not driving there. So as you mentioned, we're here to talk about holistic strategies for enhancing IAQ in commercial environments. It's a bit of a mouthful, but essentially it's really here to talk about what makes a healthy environment, especially from the IAQ standpoint. And I think if you're looking for LEED or WELL or FitWell certification, or just looking to build a healthy building and build a healthy workspace for the employees or the occupants, you'll hopefully find this very interesting. 4 chapters in our presentation today. Understanding why indoor air quality is important. I think we could probably sum that up with COVID, but we'll go through a few talking points to expand a bit more on it. We'll talk a little bit about the factors that impact indoor air quality. Talk about some opportunities to improve the indoor air quality, and then finally wrap up with just how a connected air purification system will help future ready any building.
And you did mention COVID there. I'm assuming that your business has at least changed or put a pretty good highlight on the true importance. I mean, we talked back in the 80s, we saw things like sick building syndrome and everything, and then COVID hit. And so it probably put a secondary highlight on that. Is that an accurate?
It absolutely has. And I think it's something we've talked about within our organization for over a decade. And I think just COVID, for better or worse, has brought indoor air quality as a topic to the forefront, certainly changed the industry and our business, but really, the business in general, the entire industry has kind of sprung up almost overnight, or seemingly overnight. And the science, the technology, and all of the different certifications and government agencies really have taken off the last several years. I think for certainly maybe the silver lining, if any, of COVID.
Yeah, because it affected, obviously, it's changed our lives and the landscape for every one of us in a lot of different ways. And so it's kind of interesting to watch. So it's interesting to just kind of see how we've all had to adapt in the new scenarios.
Yes, and I think now is the time for our buildings to adapt, and that's kind of the main thrust of our conversation today, right? Is how do we get there?
Right.
We can go forward one next. So when we design spaces, we tend to think a lot about the aesthetics, the lighting, acoustic panels, sound masking, making the space comfortable for the occupants, whether that's the look, the usability of it, or thermal comfort, right? We want it to be somewhere that we're enjoying the space, but we often overlook indoor air quality, and we talk about just 8 cups of water every day. That's tangible, it's obvious, and we probably would make sure that we're drinking clean water, but we're taking so many breaths a day that we're breathing in 2,500 gallons of air on average, and 90% of that is indoors. And before the pandemic, I don't think many people really thought much about what they were breathing in with each breath. And as we said, we're certainly learning those lessons the hard way, and coming out of the pandemic, there's certainly opportunities to improve that every breath we're taking. So our first topic, as I mentioned, is kind of talking about why indoor air quality is so important. We can go on to the next one. I think, like I said, it's fairly self-evident when you're breathing 2,500 gallons and not thinking about it very much, but drinking only 8 glasses of water and thinking about that probably quite often. We go out of our way as people to make ourselves healthy, right? We do a lot to improve our health and well-being. And we probably don't think much about the fact that we do spend 90% of our time indoors. COVID certainly showed us that our buildings were not designed optimally for our health. And I always love to think about this. If you think about how much time people spend in the gym, eating healthy, working out, making themselves healthy, but really probably not paying much attention to the air they're breathing in while they're there. It's a little paradoxical to think about. But what we've seen is, as I mentioned, some of these experts, and Joseph Allen, certainly one of them, whose name is probably familiar to most of the people on the call, really talking about how we've forgotten that what is forgotten a lot when we talk about health is how much time we do spend indoors, and that we've just seen that our buildings are not necessarily designed to be operating with our health first and foremost, especially respiratory diseases.
And I think we saw a lot. I mean, there was a lot of reactions early on, just more outdoor air being brought in across the country very quickly. So I mean, again, without even understanding, I don't think the full reaction of what that meant either, because it would then tax the systems that were designed, and they weren't designed to be what we were going with that either.
For sure. I would have loved to be on that call between the EPA and the CDC when they were arguing back and forth on that one, right? About the increased energy consumption versus the immediate need to clean air for people and protect them. It's certainly a balancing act that I think every building is going to struggle with in the years to come, and hopefully we can help them find some solutions, or at least some valuable information here.
And one good point, as we're actually talking through this, as we're getting started into this presentation, is if anybody does have those questions, obviously, thanks for letting us know where you are. Thanks for joining us. But there are questions. We do have another person facilitating and looking at that chat. So if there are questions that you want to raise or you think about, we'll come to questions sometimes during the middle and sometimes at the end. So feel free to put some of those things through as well, and we'll get to some or all if we can. But just again, we want to make sure that you feel this presentation, we're trying to make it for you at the same time, not just a bunch of PowerPoint slides. All right, back to you, Jason.
All right, back to the PowerPoint slides. I want to make sure we talk more about kind of the additional effects of indoor air quality on health before people say this is COVID. I'm sick of hearing about it and start logging off, because there's a lot more in the air that can affect our health and well-being. Obviously, COVID's shown a light on all these different topics, but it all culminates into each breath, and there's different factors that affect us in different ways. And one thing we've seen from some research that was done by the Harvard T.H. Chan School of Public Health, they did a study, and this is again, nothing to do with COVID, right? So let's think more about what's holistically in the air, right? It was in the title for a reason. they did a study that found that there was a 13% decrease in cognitive function when VOC concentration increased by 500 micrograms per meter cube. So an increase in VOCs, and we saw a 13% reduction in cognitive function. A rise in CO2 levels had a 21% reduction in cognitive function. And this last one is kind of a long-winded way of saying that there was with improved indoor air quality, there was a 172% increase in problem solving in crisis response, meaning a difficult task. We saw an improvement in cognitive function there. So beyond the obvious, the overt issues that we saw during the pandemic and the immediate health response that came with it, indoor air quality has been a known topic of concern for a long time, well beyond just airborne pathogens. And we'll continue to talk about them for sure, because unfortunately they're not going away. But as you can see, indoor air quality has some really interesting effects on our ability just to think, frankly, and to be effective and productive.
Well, like you're saying, I mean, obviously this is much beyond COVID, because the studies, being old like I am, I guess, is that it goes back to, I remember seeing studies on sick building syndrome back from 1984. And so we see a lot of this in a lot of different ways. I think this has just changed how we look at it. And we did, so one of the things, obviously, is a good question, is one of the other pieces is trying to get people back into the offices. I mean, so Tony came up with a question, one of the things that we have to do to get people comfortable coming back to the offices is make sure that we are truly being proactive about this indoor air quality and make sure we don't have sick buildings.
Mm-hmm. It's doing the right things, and maybe just as important, it's communicating that we're doing the right things. It's making sure that the employees know that the proper steps have been taken, not just coffee and a cereal bar, which is nice, but really the things that impact us the most around our health and well-being. We can go next. Again, going on, kind of building on top of that topic of what's in it really for all of us, there's a strong link between indoor air quality and workplace performance. Just from that perception of what we're seeing from those of us who had to experience it. I mean, it's one thing for employers to say they want their employees back in, but it's another to really listen to the employees and the people who are going to have to come out of their homes and kind of come back out into the workspace and shared spaces that they may now be a little bit fearful of. In a survey, 91% of respondents said clean air helps them perform at work. And we just saw how cognitive function was improved. So I think the science bears out what we're all kind of feeling. And then 88% of people said that clean air should be a right for all employees. I don't know what those other 12% of people are thinking, frankly, because clean air should be a right for everyone. It should be as ubiquitous as clean water and being safe in the workplace. There's more improved perception. As I said, it's kind of the perception is the reality in many ways. We've seen surveys that kind of take these sentiments that we're seeing in these surveys of people wanting to have clean air and believing it to be a right, really translating into a more positive perception of the space you're occupying, whether it's a school or an office building or a restaurant. Just seeing that what can be done is being done for their well-being, especially when it comes to indoor air quality during these kind of post-pandemic years. It's certainly making an impact, I think, to the organization, but probably also to the bottom line. So, like I said, healthy buildings are not just good for people. We would love to think that we do everything we can and spend every dollar for the betterment of our employees, but it helps our bottom line too. There was some good research that was done here by JLL that showed a 4.4 to almost 8% increase in rent per square foot when in relative to their local peers when a building invested in healthy buildings, when they invested in Fitwell or WELL accreditation. So these are very clear points that an investment in your employees is also a good investment in your business. I know that's one of the big challenges we see in the world today is, you've got to balance your balance sheets with your goals to improve your building or improve your employees' experience. And this one is kind of a win-win for employers and employees.
We're seeing that as what part of education and making sure the education of what actually the buildings are doing. You think that's again, some of it could be marketing, but at the same time, we really want the true education first and foremost.
Yeah, and that's kind of, the main point is to, like I said, it's not just doing the right things. It's also making sure that you're kind of going and getting those accreditations, or at least being transparent with the information. We don't want to see greenwashing when it comes to indoor air quality, because we'll be right back where we were in 2020. We want to see real improvements wherever they may come from. So we can talk now a bit about some of the factors that impact indoor air quality. We talked about them several times, but we can dig into them a little bit deeper now, some of the specifics of them. 80% of indoor air contaminants originate from us. I say it all the time that we are quite often the source of contaminations. There's plenty of other sources, but it's specific to some of the ones that are most common. Clearly, they are coming from us. Air quality is generally pretty good when humans aren't around messing it up. Indoor air can be 2 to 5 times dirtier than outdoor air in most cases, and most of the time. It just goes further to show us that we are generally rebreathing the same air that is being contaminated by our own occupancy. So we'll talk a little bit about what these contaminants are. You can see there kind of a list of some of the top ones: bacteria, mold, and viruses, allergens, asthma, odors and gases, and then just pollutants from smoke, anything burning, cars, wildfires, things like that. But as I mentioned, we talk a lot about viruses because that's kind of the spark that lit the fuse, but there's a lot more behind the scenes that goes into what makes your air clean.
A question came up that from the last slide, who actually runs the well and the Fitwell certification?
Meaning who does the certifications?
Right.
Or so they can be done usually through a design or an architect firm. There are accredited professionals, well APs or Fitwell APs. They are accredited to assist in the process. We see a lot of folks who both go for the accreditations and others who just kind of strive to meet some of the goals without necessarily investing in the full points and accreditation. So while you can work with your architect, or you can do it on your own if you follow the guidelines, it's best probably to work with someone who really knows the ins and outs, because there's a lot of different ways to get points and become accredited.
Yeah, because actually some of the other chats that are going on within the discussion, which is kind of interesting, is talk about filtration and things in the air and the outside air. Sometimes outside air is not always the best thing because it may be in a dirty area. And then filtration, my favorite comment about going to some owners and asking, when's the last time you changed their filters? And they say, what filters? Filters are obviously something that obviously came up as far as how do we filter things out? But some of these viruses are below what, they're so small that the filters don't have much of an impact as we would like.
Absolutely. Yep. That is why a lot of what we'll talk about is HEPA filtration versus a high MERV rating. Higher MERV is always better when you can get it. But we also know there's a lot of limitations out there that we'll talk a little bit about later on that can certainly impede your ability to improve the air quality just through filtration alone.
Yep.
Next, please. Thank you. So we talked a little about carbon dioxide. This one probably is the most ubiquitous and probably the oldest in the lineup that we look out for. I'm sure many folks on the call today focus a lot on carbon dioxide and ASHRAE, 62.1 and all the standards to meet the needs. Carbon dioxide, for anyone who doesn't know, is a naturally occurring, odorless, colorless gas. It is in every breath we take in and every breath we breathe out. It comes from respiration, but also through burning fuels, fossil fuels, wood, all sorts of things. The higher the concentration, frankly, the greater the risk becomes to your health. At the low end, you may see headaches, drowsiness, confusion, as you were saying, sick building syndrome, and maybe this is why you get a little drowsy late in the afternoon when you've been sitting in the office and you've been breathing in the same air that everyone else has been breathing in all day. But on the extreme end, you can actually see, heart problems. You can see suffocation if you're in in a space similar to carbon monoxide would be. If you displace enough oxygen, you can die from too much CO2. We've solved this problem for a long time through ventilation and continue to do so. But it is certainly something that we need to monitor for and keep an eye on just to make sure we have a safe and healthy environment.
And CO2 does have a great correlation to occupancy, because the more occupancy, you can see a direct correlation. It's pretty easy to measure that way.
It is, and it's a great proxy for the general overall health and well-being of the space. In many cases, it's a good indication of how healthy the HVAC system is, how healthy of ventilation you're able to get out of your system. But it's also, like you said, it's a great proxy for, is the air clean? And generally, like I said at the outset, it's because we are the source of many contaminations, and that's a great indicator of just how clean the air is going to be.
Well, being an engineer and the kind of the geek that I am, in my offices, I would actually carry around a CO2 meter and kind of figure out what was going on. And I had a small office one time, and if it hit 1,400, I knew why I was drowsy.
I plugged, the first day I plugged mine in my basement where my office is, it was 2,200, and I immediately opened all the windows and moved my office upstairs because I realized I was not getting good enough ventilation.
So, but I see there, I mean, obviously we have some guidance here that's coming in, because I mean, I guess that's one of the things that I do see in the industry that I don't know if there's a good answer to, that most engineers have a different opinion on what is the right threshold. I've seen below 800, I've seen 800 to 1,200. I mean, are these the levels, I mean, that you guys have seen within the different studies?
Yeah, and there's, like you said, there's some competing groups out there, whether it's the EPA or the CDC or Reset. We tend to look at Reset quite often. They look at kind of the broad body of research and come up with very similar standards to what you'll see with the EPA. But we see kind of ideal situation. A well-performing building would be under that 800 part per million threshold, although 1,000 is acceptable. Again, this is the indoor air quality. So outdoor air is usually considerably cleaner than that, just because CO2 is what plants breathe. It's what they consume. So this is kind of the natural way the world works. It's a good balancing act in the natural environment, but in the built environment, it's hard to keep that balance. And as you get above that 1,000 parts per million, that's when you start to get into some of those drowsy, poor ventilation is going to certainly, or overcrowding is certainly going to affect that. And that's when you start to see some of that sick building syndrome creeping in, and just some of those adverse effects. And when you get above that, you'll certainly see, some more really risky concerns, whether it be nausea, fainting, things of that nature. And basically, once you're into those thousands range, you're going to want to get outside that building pretty quickly.
Yeah, well, at the same time, we have to look at what is outside and decide. I mean, obviously, we've switched over to a lot of things on comparative enthalpy to understand what's better. Are we going to be starting to potentially even look at comparative CO2?
I think as the world continues to deal with a rising CO2 issue, even in the outdoors, I think we may see those comparisons where we just want to draw a line in the sand and say no worse than this indoors, and go forward with it. And that's what we've seen from some of these other standards, whether it be Reset, LEED, Fitwell, or even just what OSHA and the rest have to say about it. We're kind of moving towards that, I think, more and more, where we're coming to an agreement that there are certain minimums thresholds we simply shouldn't cross. And I would say if you're performing at under 800 parts per million, you're doing a good job.
I would think that would be fantastic. Yeah, that's what I've seen in the industry.
Something we should all strive for. Okay, next slide. So, kind of the next piece, the indoor air quality, that there's certainly one we've talked a bit about. We were chatting about earlier, is VOCs. For those who don't know, again, VOCs are organic compounds, volatile organic compounds. All that means is that they have a vapor pressure at room temperature. So these are chemicals that are going to be able to stay suspended in the air. Very commonly, they come from cleaning supplies, aerosol sprays, but they can also come from things as seemingly benign as new furniture, new flooring, paints, finishes, even personal care products, perfumes and things like that. There's a lot that are, I'd say, pleasant to us that we seek out. We all love new car smell. But oftentimes there's a lot that are not good for us, right? So some of those are formaldehyde, benzene, styrene, acetone. These are pretty caustic chemicals that we generally do not want to be breathing in. And we won't get much into the levels and limits on this presentation, but we are seeing, some more conversation around what is a healthy limit and how do we start measuring that. I think in the future we'll see more of that coming on. Some EPA studies have found VOCs up to 1,000 times higher indoors than they are outdoors. So certainly something we need to monitor and keep an eye on, and just make part of the air quality suite of kind of concerning categories. Long term or short term, you'll have similar things to CO2. You may have headaches, asthma, triggers, allergies, nausea, some of that very similar to CO2. But long term, there can be some serious complications with liver and kidney disease, cardiovascular diseases. Really there's some serious side effects that can come with long-term exposure to VOCs as well. There are some so one of the things that we've seen, indoor air quality sensors are monitoring these, and we are seeing again some the several standards like we were talking about with CO2. There are kind of good thresholds and bad thresholds, and we're starting to see those kind of coalesce in the world today as well. PM 2.5, you were saying you were kind of the engineering geek. PM 2.5, the particulate matter, this is the one I geek out on. So this one is a bit of my favorite. This one is probably most interesting because it is so difficult, I think, for us to visualize and kind of understand the impact that such a small amount of solid or liquid matter suspended in the air could have. Mainly because of the size of this. We're talking 2.5, 1 micron in size. These are ultrafine particles that are able to be breathed into the lungs, get deep into the lungs so much so that they can make it into your bloodstream. So these are absorbed into the body when you get into these PM1 and smaller particle sizes. They can even cause lung cancer. They can get beyond the lung tissue and into organs and kind of get lodged deep into your body. So these are, for me, the most interesting, especially when you think about viruses, how much COVID, for example, brought us to our knees as a society. And these are, 0.1 micron particles that are doing a lot of harm to our bodies. But well beyond that, we're seeing these particles can come from soot, smoke, wildfires, certainly a big contributor, even down to our brake pads and our tires as they wear off of our vehicles. There's so many different ways that particulate can get into the air. And we're seeing some guidance, again, around this that's actually probably come down a bit over the last several years from the EPA and World Health Organization and Reset, among others. We've seen, PM 2.5 should be less than 12 micrograms per meter cubed over a 24-hour period. And your average annual concentration should not exceed 5 micrograms per meter cubed. And micrograms, ask any child, right? That's a very small thing. Micro means small. It's a very small amount, but it can do quite a bit of damage to you if you're breathing in quite consistently. So I mentioned viruses. I mentioned them being very small and having such an outsized impact on our health. We see that with the flu. We see that with COVID. Not just the human impact, but the economic impact. Certainly, we all experienced it. We may know someone who, suffered during COVID or during the pandemic, and I'm sure we've all had the flu at some point. And even the toughest of us are in bed with the sniffles because of a tiny little virus particle. But we've also seen a massive economic impact. Absences throughout the last, the average over the last several years has been $225 billion in lost productivity. And just a single sick day can cost almost $1,700 to an organization on average. So we're seeing not just the human impact, but the economic impact. and I think, again, we've probably learned that lesson the hard way with many things, whether it be natural disasters or pandemics. But more often than not, if we are not prepared properly, we pay the cost personally, but also economically. ASHRAE 241 has come out in the last year and a half or so, I guess. And one of the great things about that is it really set out the new IAQ requirements and recommendations that go beyond what 62.1 did in terms of ventilation specific to controlling infectious aerosols, which has been a great tool and really part of this, probably the fulcrum on which this conversation moves, because we are able now to really look at indoor air quality holistically and how can we get there with the given infrastructure of a building and these additional resources and technologies that we have to get those equivalent air changes, whether it be filtration or disinfection through UVC. We've seen 241 kind of set out new options for us and opportunities to improve indoor air quality.
Because that's the main highlight that we've also seen from these is there's at least now the funding to actually study a lot more of this and come up with standards, correct?
Yeah, and it's, the focus alone has really driven that. Like I said, one of the silver linings about COVID is it really opened up the floodgates of research and regulation and just conversation around indoor air quality. And I mentioned being such small particles, and I read the other day some interesting little tidbit from the National Institute of Health that said if you took all of the COVID virons, all the particles from everyone who was sick throughout the pandemic, put them all together on a scale, it would weigh 22 pounds. And I just think that's fascinating. As I said, I geek out on this piece of the category really because when you think about how small those particles are, when it doesn't take much to really upset the world, but also a business, right? So if you think about those things and how they affect your business, whether it's that lost revenue or lost productivity, it's really time for us to pay better attention to it. So those droplets that contain those virons, in a single sneeze, an infected person can sneeze up to 100,000 particles. A cough can do almost the same number, and those particles can travel about 3 to 6 feet for those larger respiratory droplets. Which, if you remember, during the pandemic, social distancing was 6 feet for about this reason. Initially, we thought that it was simply a cough or one of those respiratory droplets that was going to get you sick. After a while, we learned that they can stay suspended in the air for quite a while. A sneeze can travel up to 27 feet. But we've also seen some studies that have shown some of those viruses can stay active and be transported throughout the air by HVAC systems over 150 feet sometimes, according to some of the studies that have been done. It really just goes to show you, like we mentioned early on, that there are certainly benefits to increasing your MERV filtration whenever you can in your building. But a localized HEPA or H13 filter is going to be able to do more good in that immediate area to help reduce that airborne particulate, especially when it comes to some of that constant reintroduction of contaminants when it's someone coughing or sneezing or who is sick and kind of spreading some of those germs.
And you made a good point that actually I was just thinking about this weekend. I was talking to a friend of mine. You want to increase the effective MERV rate, not just the filter, but then a lot of people, they just changed MERV filters and then they burned out their HVAC ventilation system because they didn't have the static carrying capability to operate at such a high MERV. Mm-hmm. So trying to figure out a way to get that MERV rating and truly effective MERV rating is kind of a harder thing to do.
Yeah, it works great in theory, and then in practice, it may not work out. And we've seen a lot of people who went to MERV 13s and realized pretty quickly that their system couldn't handle it, and they were freezing out chillers and had to come up with an alternate plan. And I think we've seen that time and again. And as we move forward, and hopefully as more regulations come out, and we get our arms around the best way and come to a consensus of the best way to protect ourselves for any future outbreaks or any future issues, or even just the things we know about today, wildfires and other things. I think we'll learn more and more that as I was saying, ASHRAE 241 kind of helps support that in saying, okay, we got through the pandemic with some solutions that were kind of stopgap. Let's look at a more long-term plan here and see how we can make our buildings more healthy. Okay. So we've talked about this a few times, kind of that the way COVID has changed ventilation and the way we view our buildings. It's probably the silver lining that we've seen in our industry. People kind of taking a better look at it. But we mentioned earlier some of the economic impacts of what we've seen during COVID-19, but it goes well beyond that. I think for everyone on this call who's either working on a clean building, trying to improve their building, or working to help somebody else improve their building, we saw that 59% of building owners said they will invest in IAQ solutions for their buildings going forward. So it was really encouraging, I'd say. Again, just that silver lining for me is to see that people are taking the right steps. And, I think the financial positive for them will come, but we are seeing that investment made up front for the health and well-being is enough to get people motivated. All right. So we'll talk a little bit about how to improve indoor air quality. And if you've been paying attention thus far, I think you'll probably have already figured out, right? Not much of a big reveal here, but we'll talk a little bit about some of the different ways we can improve our indoor air quality. So according to the EPA, the three main strategies are source control, improved ventilation, and air cleaning. And the first one is kind of what we did initially during the pandemic, which was kind of send everybody home, right? Let's control the sources, especially of a virus. Eliminating those sources and shutting down worked temporarily, but not a long-term solution. And beyond viruses, there's a lot of other sources of airborne pollutants that we need to worry about. And I think those are all being addressed in their own different ways, whether it's CO2 or VOCs or, wildfire smoke or exhaust from burning fossil fuels in cars. All these things are contributing factors, but clearly we can't eliminate all of the sources. We need several of them to live for society to carry on. So we need other options. Improving ventilation, like we talked about, a great solution when the outside air is better than the inside air, but for a lot of the reasons I just mentioned, wildfires, car pollution, things like that, it's not always a great option. It doesn't always work out to the benefit. And like you mentioned before, you then have to heat and cool and dehumidify that air once you've reintroduced all that extra air into your space, which can have a pretty costly effect on the overall energy consumption and usage and expense of the system. And then finally, air cleaning, which is clearly near and dear to my heart. These dedicated air filtration systems are capable of delivering enough clean air to the space when properly sized, and are a great way to kind of supplement what we're already doing when reducing the sources and improving the ventilation of the building. As a supplement to those options, indoor air cleaning can certainly get us a lot closer to the healthy buildings we need. I just wanted to mention on this, it's always interesting to see kind of what the health experts have to say, and the engineers and kind of the guys who are on the cutting edge of all of these. But I just love this quote of circulating more air through a space can decrease the risk and probability of pathogen transmission to propagation. I probably could have saved myself several slides just by reading that, right? Sums it up nicely. But what I think it also illustrates is, given what we often see outside, especially in urban areas, in terms of outdoor air quality, the point is we need a solution indoor to really cover us from not just what we're breathing indoors, but also what we might be reintroducing from the outdoors. So that kind of brings us to that supplemental conversation of supplementing the HVAC system and the ventilation that we need throughout the system. But how do we get there, right? And how do we account for that? So we talk a little about air changes per hour. You probably hear ACHs fairly often, and now with the advent of 241, you also probably hear EACHs quite often, which is an equivalent air change. it really talks about how do we measure that we've got enough air to clean the space and provide a healthy environment. EPA did an analysis and showed that the average commercial building was getting about 2.2 air changes per hour. Essentially, that means the entire volume of the room is replaced with quote unquote fresh air, every 25 minutes or so. But that ranges, depending on the building, based on their study, from 0.3 to 4.1 air changes per hour. We've seen recommendations in the 5 air change per hour range quite often, or better. What we're also noticing is, in order to get to a 99% clean range, you'd have to have at 1 air change per hour, it would take about 7 hours. At 2 air change per hour, it's going to take you about 3 hours or so, right? So we really aren't able to get there with the infrastructure we have today. In most buildings, it's going to be a challenge for you to get to that 5 air change per hour rate that their CDC has been recommending without making some sort of major overhaul or adding a supplemental equivalent air change per hour. You can go to the next slide. Again, just kind of reiterating that and kind of touching back on that point. In 2019, the CDC recommended a target of 5 air changes per hour to reduce viral load. It was a bit prophetic, I would say, that it came out in 2019. And if you would take that average of 2.2, as I mentioned in the last slide, you would need or want to get additional EACHs through a cleaning unit, through an air purifier, ideally a HEPA air purifier. So you're able to get to that 5+ goal. That's going to give you essentially refreshed air every 12 minutes or so. You're certainly welcome to overachieve that, but based on what we saw during the pandemic, I think it was clear that we just simply didn't have the buildings and the ventilation we needed to be safe. And we paid the price for it, but we've learned a lesson as well. There's some warnings and recommendations we should heed, and there's a way to get there through supplemental air purification. So ventilation standards have certainly changed a bit over the last couple of years, and I think we'll probably see a bit of the stepping on the gas for those as the next couple of years unfold. There's a lot of, if nothing else, COVID also gave us a very large data set to study and to see what buildings were in fact healthy and which ones were not meeting our needs. It'll give us a good chance to kind of evaluate what investments have already been made and what really does move the needle for us to create a healthy built environment. Building on what the CDC said, we've seen ASHRAE 241 kind of talk a bit about specifically airborne infection risk management. The standard establishes requirements for infection risk management for periods of elevated disease transmission. So it's different from 62.1 or 62.2, which really talk about specifically outdoor airflow, increased outdoor ventilation, focused very heavily on CO2. It's much more nuanced than that, but I don't think we have the time to get in all the details today. But certainly the focus of that, I think, was missing a bit of the what we dealt with the last several years. So the standard 241 sets out require flow rates for pathogen-free airflow. And which I mentioned that because we want to make sure that we're cleaning that air properly in order to reintroduce it to the space. It's a significant step in prioritizing indoor air quality. It's designed to create a healthier built environment. It provides requirements for design, installation, operation, and maintenance of the supporting systems. So really what it does is outlining, like I was mentioning before, clearer guidelines of how I can utilize additional technologies beyond just ventilation and quote unquote fresh air to improve my building's air quality for the occupants, and it sets out those guidelines of how I can partner in some of these supplemental technologies.
Yeah, and we are doing a time check. We got about 15 minutes left. We did have a question, and one person asked, when I was talking about effective MERV rating, this is kind of where that comes into play, is what is the effective filtration? And so when I talk about effective, I think about all of these different things, whether it's UV, whether it's ionization, whether it's Did the filters get installed properly? Were the filters there? Things like that. Because just because you have a HEPA filter doesn't mean you have HEPA filtration. Just because you have a MERV 13 doesn't mean you have MERV 13 filtration. If there's gaps between filters, if the filter racks aren't done well. So that's when I talk about that. There's a lot that goes into what is the true filtration, what is that equivalency. So.
And I can talk a bit faster and move along.
Hey, I got plenty of time. You've got a flight to catch.
I have a bus to catch before I can catch a flight. So I'm not too excited to do it, but I have to do it. So yes, I agree. At some point I will have to bail. So I noticed there was a question in there about ionization. So we can talk a little bit about the three approaches to air treatment as we've categorized them: capture, kill, and combine. Capture is exactly what it sounds like, whether it's carbon or HEPA. Essentially, you're running air over a medium in order to remove either the VOCs, the odors, or the particulate matter. We've also seen kill being recommended by CDC and ASHRAE to provide some of those equivalent air changes. UVC is capable of irradiating to kill, using light basically to kill bacteria or render viruses inert. It essentially forces a mutation in the RNA or DNA that makes it unable to reproduce. These two technologies have been very widely studied, and from what we've seen, probably the two highest promoted type of resources at our disposal. There are others: ionization, ozone, PCO. There's several other emerging technologies. There are still some testing to be done. I think the CDC has kind of said that looking at the various forms of technology, capture and kill are kind of tried and true. These other emergency technologies are not. I think the testing is still TBD before they're willing to kind of put a seal of approval on them. But there's certainly some promising cases to be made for several of them. I think there's also some cons. There's a lot of print on this page that we will not get into for the sake of everyone's mind and also for the sake of time. You can go next. So kind of looking at the two different methods we could get to purifying the air, those being centralized and localized. When I say centralized, think of your HVAC system, and localized would be an in-room air purification or disinfection system, like we were talking about. So we can go to the next. HVAC system, as we're all probably very familiar, are largely designed for thermal comfort. We certainly do see CO2 and air quality be part of that equation, although I would say, as we've kind of discussed, it's probably secondary to the thermal comfort. To improve indoor air quality, we'd essentially have to modify that system in some way, like we were talking about before. That might mean a higher MERV-rated filter, induct UV, increasing outdoor airflow. But those do come with some disadvantages, of course, whether it be kind of extra wear and tear and reducing the life of the system, being less energy efficient, or just the cost of doing those renovations can be quite excessive. Certainly, there are several systems out there that do a great job of providing excellent indoor air quality, but I think we've also seen the vast majority of buildings that are older tend not to have the most state-of-the-art systems and generally do not supply proper ventilation for our purposes. Next. So the alternative, right, is standalone purification. These are localized, primarily focused on airborne contaminants. They're primarily not driven by thermal comfort. They're mostly looking for air quality concerns to respond. They're easy to deploy. They have generally a higher level of filtration, mostly a HEPA filtration. And one thing I think that I love about them is that they're highly visible. They not only do the job, but they also make sure that people in the space know that they're in a clean, safe environment. There's certainly some disadvantages, that because they are a bit overt, they can be intrusive sometimes and stand out in the space. Generally, most of them have a minimal amount of monitoring available. So you may be getting the air quality, but you're not getting the visualization of that data. And they require local control generally. They're not something you can control from a centralized point. So that brings us to kind of how a connected air purification system can make your building future ready and kind of address some of the concerns of both of those centralized and localized systems. A connected or networked IAQ system is one that's going to be consistently monitoring the air quality and reporting that air quality back while also mitigating those concerns. Quickly, I'm just going to touch on the previous slide. You can just go back one real. You may or may not know what this button does in your car. I find that most people don't, or many people don't. This is a recirculation button of your HVAC in your car. Generally speaking, if you are driving behind a garbage truck or drive past something that smells, you may have had this experience where you turn that on and it's going to stop the additional influx of that smell, of that contamination. It's funny to me, and I bring this up because we tend not to be too concerned about the air quality until it's an odor. It's something that is tangible to see. But if you go to the next slide, you'll see that sometimes even without an odor, there can be some really poor air quality conditions that need to be addressed. So what is on the screen here is a 3-day snapshot of the air quality in a call center outside of Chicago. So if you all recall the wildfires we had about a year ago, the wildfire smoke in Canada was drifting down into the States. During late June, it had wafted over Lake Michigan and into the Chicago area. In this call center, they had air quality monitors. Generally indoors, the smoke smell wasn't too bad. It wasn't noticeable as it was outdoors. This building has a pretty state-of-the-art HVAC system. And what you see, that large spike on the 28th, was that system booting up in the morning because the outside air was quite cool. It was bringing in additional outside air to make it just more efficient to run throughout the day. The downside of that was by doing so, it was dumping wildfire smoke into the building. So they were able to identify this issue, reach out to the building control manager, and make a quick adjustment to the HVAC system. And you can see on the 29th, the outdoor air was essentially the same in that unhealthy zone, but the indoor air was much healthier. And I bring this up to say that knowledge is power, right? Clearly, having some knowledge about what's going on in their air quality in that space gave them the ability to make an immediate change and quickly improve and dramatically improve the indoor air quality for those occupants. So some of the standards we talked about, LEED, WELL, and RESET, I'll just touch on lightly because, again, I know we're running kind of long. All three of these, as you note in the words below, have given due credence finally to indoor air quality, but mainly through monitoring. They've all mentioned kind of the standards we need for air quality to meet, but all are incorporating monitoring one way or another into their requirements. As I mentioned, we talk a lot about what makes us healthy, and indoor air quality has become a requirement for these. Just a quick note, 81% of people think that indoor air quality should be mandatory. I'm sure that was much lower in 2019, but as I mentioned, knowing the conditions in your space are certainly going to make you act differently about, as we just saw in that one example, and it just makes that invisible threat visible to you. Real quickly on testing versus monitoring, both are great assets to have when you're trying to conduct an air quality assessment and trying to make sure your building is as healthy as it can be. Some pros of the testing are that you're really going to get an accurate idea of down to probably specific chemicals, specific pathogens, and specific germs living in that space, and a much broader range. But they tend to be more expensive. They tend to be infrequent. It's difficult to build trends with the data, and the equipment is also quite expensive. So it's probably not something you're going to invest in. Monitoring, on the other hand, is significantly less expensive to start. It will be a continual air quality assessment. You'll be able to build trends, but it is going to be a little bit more limited in the scope of what you'll be able to identify in those sensors and with those machines. So really, what is a connected air quality management system? I mean, quite simply, is as we mentioned, is going to be a deployed system throughout your space that has sensors that will be able to monitor the air quality, all the various parameters that we were mentioning. It'll be able to report back to them, but not just monitoring and reporting. It'll also be able to mitigate those concerns, as we talked quite often about kind of that localized and the benefits of localized filtration. That's ultimately what we're going to look for here is being able to not just monitor and report, but also mitigate. So, you know, a building indoor air quality can literally change with the wind, as we saw with that wildfire example. We know that the conditions of Monday are not necessarily going to be the conditions of Tuesday, and so on. So having a system that can respond to the changing conditions and adjust accordingly, and then report back to those over a continued period of time are kind of essential to a modern workspace and clean air. Thank you. You know, we talked a lot about the increase in energy consumption that we saw with a lot of the response to COVID. We've spent a lot of time, a lot of energy, and a lot of money trying to make our systems, our buildings, and our world as sustainable as we can. Just as a note, we've seen going from a MERV 8 in one study to a MERV 13 increased energy usage by 8 to 11% over the entire system. A localized, connected air quality management system can provide that clean air with a nominal energy consumption, and you know, do it for a lot more cost effective and a lot more sustainable measures. Another thing we see quite often is kind of this need for buildings to be smarter. Buildings are getting smarter and smarter every day. In order to optimize the efficiency and the effectiveness of that building, it needs data, right? In order to be smart, it needs data. So it's really important to be able to incorporate a variety of sensors that are able to feed back that information into the building management system or the BAS systems. Being able to communicate with that building software and integrate fully into it is going to make a huge advantage for future buildings. So finally, you know, we are seeing those new standards. Both ASHRAE and the EPA have recommended indoor air cleaning localized devices. Both of them have kind of gone out into the most recent recommendations, essentially stating that they're a cost-effective way of improving the indoor air quality without having to do expensive upgrades like we're talking about to your HVAC system. And I apologize for flying through those last few slides. I promise this is the last one, and hopefully we'll have a little bit of time for some questions before I have to jet out of here. In closing, I just wanted to, you know, when designing a spaces, we have to consider indoor air quality, and I think we certainly are. And hopefully we all continue to. Secondly, using IAQ sensors for continuous monitoring to identify areas of need, especially to understand the risk of virus transmission is going to be table stakes, I think, for buildings of the future. Following CDC guidelines, implementing a distributed IAQ system with true HEPA or H13 to supplement your HVAC system and obtain the recommended 5 air changes per hour is a smart and cost-effective way to achieve those goals. And utilizing standards such as reset, air quality index to determine safe and optimal levels of PM 2.5 in particular is something that we are at a point now where we have the technology to do so. And I think the urgency and the need is there as well.
Well, I do think that takes us to our last slide. So, Jason, thank you. I know we're right here at the top of the hour. We will definitely stick around for a couple of minutes asking questions, but we may be chasing Jason over to a bus. But anybody who has joined us, thank you for joining the Engineers HVAC Podcast with your guest host today, Chris Adams and Jason Jones. Obviously, I think we had Mitch online. Didn't ever get to do that quick tour, but a 30-minute presentation can always take a little longer with a moderator, correct? So I just slowed you down mainly. But I thought it was a great discussion.
Added value, though, so I appreciate it.
So some of the things that we can do, and Heather, if you want to kind of put it to that camera just from that standpoint, but while we do that, get that over to that tour camera. We did have a couple of questions talking about like MERV 13 filters and pressure drops, and we talked about it a couple of times that can you do things like that? Well, the answer is as an engineer, our answer is always the same. It depends, right? Sometimes you can update, sometimes you can upgrade, sometimes you can't. Sometimes it's one of those things you definitely have to look at. So we do have Mitch online there with the camera looking at some of those devices. So
yeah, I think Tony wanted us to let everyone know that is the PDH is officially in the books.
Yep, the PDH is officially in the books. We have spent our hour. So for PDH certificates, email Tony Mormino at tmormino@insightUSA.com. It's down across the bottom there. Obviously, he will get those out. That's one of the things I didn't agree to guest host for him. I made him send all the certificates. So, Jason, I don't know if there's anything you want to highlight with Mitch on the tour.
Yeah, I'm going to have to jet out of here, like I said, to go catch that bus, which sounds super exciting, so I can get out to Chicago. I'm expecting more delays and cancellations, but I'm gonna soldier on. But I will just say thank you to everyone, and I'm going to turn it over to Mitch out there in Chicago, in our headquarters, in our showroom, who is going to show you some of our connected air purifiers.
All right, great. Thank you, Jason.
All right, can everybody hear me?
Yes, we've got you, Mitch.
We can hear you now, Mitch.
Excellent. So I'm on. Thanks, Jason. Thanks very much. Hey, team, I'm kind of doing double duty here. It's actually running the camera as well as the product. But we did want to just cover it very quickly with you. And what you're seeing here is what we call our recess unit. It's a 2x2 that basically fits into the grid. And I'll show you here in just a second that it basically disappears within the environment. But within these units, what's very unique about them is that they actually use motion, sound, odor, and particulate count to activate, as opposed to someone having to come in and turn them up and down. So these will actually respond much more quickly to what's going on in the environment versus an HVAC system. As you know, they're primarily designed for thermal comfort, where we're targeting indoor pathogens and indoor, odors, et cetera, et cetera. So as a matter of fact, I'll show you this unit, as you can see, simply hangs from the plenum with aircraft wiring. Very simple to install. Any certified electrician can do it. They will say it's as simple as putting in a light fixture within it. So I'll have you take a look at what it actually looks like once it's installed. So hang with me here as I do a little camera work, but that's the actual unit right there installed in our facility here. So as you can see, even the most picky architects don't think that's too bad. So we try to integrate as best we can with that. We also offer a unit that has twice the airflow. So the idea behind these is that we are creating equivalent air changes that complement an HVAC system. So what we do is we recommend these for shared in public spaces, such as conference rooms, restrooms, break areas, classrooms for sure, because as Jason had commented, we occupants are the source of the contaminant. So the idea behind these is that's what we're targeting. And so these units use, and I'll show you this as well. I hope we still have some of you on. We'll see. But they all use the same filtration system. Very simple to change out. Just pop this out and the cartridge comes out. You've got a pre-filter for the big stuff. What you see in black is activated carbon for your VOCs. And then what's doing the real work on the inside is the HEPA filtration. And these have an annual lifetime for them for these. And again, I'm hoping this is, simple to pop back in. So you will see these units in every single one of our new array system products. So, and then finally, each one of these not only have sensors for their activation, but they also monitor indoor air quality per reset standards. So in addition to motion, sound, odor, and particulate count, it's measuring PM1, 2.5, 10, VOC, CO2, relative humidity and temperature, and I'm forgetting one, pressure, I believe it is. But the whole idea is that you can find out and get data on what's going on within your environment. So you can see the rooms that aren't getting enough airflow, et cetera, et cetera. But this takes the pressure off your HVAC system by, again, creating equivalent air changes where you need it. And that's where we are. So want to thank everyone for joining us. And again, if you have any questions, let us know. And again, we really appreciate you joining us today. Have a great day.
You actually answered our last question really well, because one asked about can you elaborate on how it reduces cost? And it was just and it goes back to exactly what you said, is the EACH, the equivalent air changes where that money savings come from.
Exactly. By the way, our units use about actually less energy than a 48-inch LED light fixture. And because of the units being able to activate themselves, they will reduce their energy consumption if nobody's in the room. Why should they run if, we don't have individuals in there to protect? So very energy efficient.
Great. Well, again, thank you everyone for joining the Engineers HVAC podcast. Hopefully some of you were able to stay on for the marketing portion of that, but obviously we wanted to make sure that we were covering that PDH hour correctly and making sure you were getting your money's worth as part of that. So it has been my pleasure to host on behalf of Tony Mormino and the entire Insight and Hobbs teams. We definitely appreciate your attendance. Thank you and have a wonderful day.